Hi, this is the third video in the series of assignment videos for the Advanced Database Management System program at the University of South Florida. In this video, I will be discussing the concepts of query optimization with indexing. I will now share my screen. First concept explained here is selectivity. For this purpose, I've used a data set that gives details about airlines and which has 450,017 rows of records and 22 columns. I've also used the movies table in order to explain a few of the other concepts. Selectivity. Selectivity is a concept whereby indexes are used to select a specific set of data. In order to analyze the outputs of the queries, I've used the auto trace feature. For the first experiment, trip ID is the index that has been used, and I've run a series of queries in order to experiment at which point a threshold value is obtained, whereby above which a query starts using an index. So from the series of runs, what I have found is that at the 360,000 record and above, an index is used. That gives me about a 20% threshold value above which the use of an index is not recognized by the query optimizer. Now, the second concept is to show how indexing works. For this experiment, I've used the movies table and a few with related tables as well. The movies table has 283 records with 14 columns. The experiment starts off with the execution and analysis of a simple query without an index. This is followed by the analysis of the same query with an index and then a comparison of the two scenarios. The exercise is successively repeated for a few more complex queries. Using the rough idea of a 20% threshold as above, I've come to use 271 as a rough idea to use my select statement with and without an index. So on execution of both queries, I find that using an index considerably brings down the execution time of the simple select statements. Even for complex queries, for instance, the select statement where I've used to join between the movies table and the casts table, I found that using an index brings down the time frame from around 0.033 seconds to 0.031 seconds. The third concept examined here are the concept of primary keys and indexes. By inserting along with the use of an insertion of a new record. Since an insertion does not give statistics from the auto trace feature, I have used a few other statistics in order to understand the performance. What has been observed is that when a record is inserted without having a primary key in the table, the number of logical reads, that is the number of consistent gets and the number of DB block gets, comes to 79. Now, if this is run along with a primary key, if the insert statement is run along with the primary key, then I find that the number of logical reads has increased. What this shows is that when a primary key is assigned to a table, a constraint for uniqueness has been imposed. And so the DB needs to make this check prior to allowing any new record to be entered. And hence, the number of logical reads has increased. The fourth concept examined is indexing for different query types. The two query types being examined are point queries and range queries. The point query, I've gone back to the airlines table, and from which the trip ID I've selected is a particular value. Following this, I have done a simulation of 10 runs to get the average number of seconds taken to run this point query. So I've done the similar for a range query, the range being the trip ID greater than 370,000. So in both cases, I've taken conditions such that an index is being used. And what I find is that with indexing, a better performance is found for point queries as compared to range queries. The fifth concept examined is the function-based indexes. For this purpose, I've conducted following experiments: multi-column computation without a function-based index. So here the route is the computed call attribute. It concatenates the two columns, origin and destination. This one uses a simple index, which is the trip ID, and the average time taken as before simulated is around 0.0456 seconds. Then when I've used the same route function as an index, I find that the time has reduced considerably from 0.04 to 0.0311 seconds. And then when when I've used several indexes where one of them is a function-based index, what I find is that that time for execution has increased. This is because using a function-based index in concatenation with other indexes is an expensive operation and increases the execution time of the query. The last idea examined here is database programming. For database programming, a simple stored procedure has been created which takes 3 input variables and 8 output variables. When the query is executed, so for this purpose, the get flight info is the stored procedure created. Once the query is executed, the user is prompted to enter the values for the 3 input variables. Here I've entered the origin airport code as MIA, destination airport code as STL, and flight date as 1st Jan 2017. If this data is present in the database, then I get corresponding values for the output field. Now, in case I've given an incorrect input, such as an airport origin code of MXA, which is not present in my database, then an exception is encountered and the exception code is triggered. Within the exception code, the values are given, each of these attributes are given default values, and this is what is displayed on this account. That brings me to the end of this assignment. Thank you very much.